We have quite a lot of information that's going to be packed into this video, so I hope you have your thinking caps on. This is Exponents 20A. And of course, I have links in the video's description to help you. If you become lost or confused, try watching those. We use exponents to simplify problems that involve repeated multiplication. And the exponent tells us how many times to multiply the base number to itself. And be very careful, it's not by itself, it's to itself. So if we see 2 to the third power, which can also be called 2 cubed, but this is 2 to the third power, it means we have 3 of these 2's, these bases. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 2 to the third power equals 8. 2 cubed equals 8. If we see x to the third power, it means x times x times x. See how it does not mean 2 times 3? Because that would be 6, wouldn't it? It means 2 times 2 times 2. If you see 2x squared, this is the base, this is the exponent. The 2 has nothing to do with it, with that exponent. See that? This would be 2 times x. This exponent is only affecting that base x. If we see 2xy squared, or to the second power, it means we have 2 times x times y. See how the exponent affects the y and not the 2 or the x? If we have 2 to the first power, well, that's just 2, because any base with an exponent 1 equals that base number. If we see 2 to the 0 power, that equals 1. So any base with an exponent of 0 equals 1, and it doesn't matter how big the base is. 975 to the 0 power equals 1. 99 million to the 0 power equals 1. All right? So here's what I want you to remember. This big number is the base, and that's the exponent. And the exponent only affects the base it's directly next to. So 5n squared would be 5 times n times n. This 2 exponent does not affect the 5, okay? If we don't see an exponent, there's actually little invisible 1's there. See? That's 2 to the first power, x to the first power. See? And they don't write them, but they're invisible and they're there. On the calculator that they'll lend you for the test, we can use the x to the second power key. It's the x squared key, and it's right here. See it? To raise a base number higher than the 2 power, we use the x to the y key, and that's right there. See it right above the c? So to find the value of 15 squared, we enter a 1, a 5, and that x squared key. And the display is going to show us 225. That's the answer. That's what it equals. We're solving 15 times 15. If we want to find 5 to the 4th power, because this 4 is bigger than the 2, we don't use that x squared key. We use this x to the y key right here. We enter 5, the x to the y key, and then 4 for the exponent. And the display is going to show us 625. We're solving 5 times 5 times 5 times 5. You should try practicing this on a scientific calculator. And if you don't have one, you can turn your cell phone sideways. And then your cell phone calculator will turn into a scientific calculator. And you may not see this x to the y key or the x squared key, but you might see y to the x. That's the same thing. It's telling you that's the exponent. So if we wanted to do 5 to the 4th power, we would enter the 5, hit that y to the x key, and then 4, and that would give us the same answer, 625. Okay? Try playing with that. Try practicing that. Our number system uses groups of tens. When you get 10, you go on to the next place value, don't you? So powers of 10 can tell us how many zeros will follow a 1. Now, be careful, because this is for powers of 10. It doesn't say that this could be a 26 or a 17. It says 10, okay? So if we have 10 to the first power, remember, if you don't see an exponent, it's actually got that little 1 there. It just means that base number, 10. And that little 1, look, it's telling us how many zeros are coming after the 1. 10 to the second power, well, that's 10 times 10. That's 100. That little 2 exponent is telling us there's 2 zeros there. 10 to the third power tells us there's 3 zeros. 10 to the fourth power tells us there's 4 zeros. See that? We also have negative exponents. They represent fractions or decimals. 10 to the negative first power actually means 1/10. If you have 10 to the negative first power and you're trying to do math and you want it to be a positive exponent, you could just write 1/10 or 0.1, and now it's a positive number. 10 to the negative second power would be 1/100th, or 0.01 as a decimal. 10 to the negative third would be 1/1000th, or 0.001 as a decimal. So the negative exponents tell us how many decimal places we'll have, or how many zeros the denominator will have. So this -2 tells us we're going 1, 2 for the decimal, see? So this 1 gets shoved farther into the decimal places because of that negative exponent. Or that's how many zeros are going to be in the denominator. See that? But it doesn't work for like other numbers. If you want to do other numbers, we can use scientific notation, and that'll help us write very large or very small numbers quickly. If we have decimals that go way into the decimal places or very large numbers like this, we can condense them using scientific notation. And scientists and engineers, physicists, they all use scientific notation, and it helps them write quicker. Here we have our hundreds, our thousands, our millions, so that's a billion, isn't it? So to write 1 billion, if you don't want to write all these 9 zeros, we can just say 1 times 10 to the 9th, or 10 to the 9th power. It's a lot quicker to write this than this, isn't it? If we have 2,300,000,000, we can just write 2.3 times 10 to the 9th. If we have 2,350,000,000, we can just write 2.35 times 10 to the 9th. We always put one digit to the left of the decimal and then count the places to write the correct power of 10. So we count the hops. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know it would be 2.35 times 10 to the 9th. See that? Now, Mars is 33,900,000 miles from Earth. In standard notation, this is called standard notation, when you write it the regular way, and this is scientific notation. We can write this in scientific notation by counting the hops, 1, 2, 3, 4, 5, 6, 7, so that it would come in between this 3 and that 3, and we would have one digit to the left of the decimal point. We'd have 3.39 times 10 to the 7th power because there were 7 hops, see? You can't put 33.9. You can't put 339. There has to be a decimal point with one digit there for it to be scientific notation, all right? A human hair is about 7/100ths of a millimeter in diameter. That's 7/100ths, or 0.07, right? We take 2 hops back and can do 7 times 10 to the -2. Negative second power, see? This would be standard notation. That would be scientific notation. Now, there's going to be questions on the test that may say, write this in scientific notation, or which one of these is this number written in scientific notation. So you need to be able to identify this, that it's got a digit to the left of the decimal point, and then you count the hops to the digit, to the decimal point, okay? We can solve and convert to scientific notation. You might have problems like this on there. I know there were in the practice test. If it says 20,000 times 7, and you need to write it in scientific notation, well, do the 20,000 times 7. Get 140,000. Then change this 140,000 into scientific notation, okay? That would be 1, 2, 3, 4, 5 hops to put it in between the 1 and the 4. Right? So our decimal's there. So we have 1.4 times 10 to the 5th power because we had 5 hops. If we have 5,000 times 9,200, we can just multiply it with our calculator real quick. And we get 46 million. We can write the 46 million in scientific notation. We count the hops. There's 7 of them to go in between the 4 and the 6. So we have 4.6 times 10 to the 7th power. Now I covered this in Algebra I in Chapter 5. All of these videos in Chapter 5 are going to help you for this lesson, all right? you're going to have questions like this. It's going to say, which is greater? Well, you're going to have to write these in standard notation to be able to see which one's greater. 6.4 times 10 to the second power, well, that means we're going to move this decimal point. The 6.4 is going to have the decimal point moved 2 places. We're going to have to put a 0 as a placeholder, so that's 640. 3.05 times 10 to the third, 3.05. We need to move the decimal place 3 hops, 1, 2, 3. That's going to give us 3,050. 7.28 times 10 to the negative second power, 7.28. Because it's to the negative second power, we've got to move the decimal the other way, 1, 2. Put a 0 as a placeholder. Now you can look at them and say, oh, this is the one that's bigger right here. That's the correct answer. See? So you're going to have to solve them and put them into standard notation. That's no biggie, all right? Which is the least? 9.6 times 10 to the third or 960? Well, if we have 9.6 and we move the decimal 3 hops, it's positive, so we're going to go 1, 2, 3. We're going to have to put zeros for place values. We have 9,600. So we know this is the one that's larger. This is the one that's smaller. Whoops. So we want the one that's the least, don't we? So it would be this one. That's the one that's the least. Got to answer what it's asking, all right? Now, this might become very confusing for you, and I don't want you to panic. You can watch this video a second time. I said there's going to be a lot of information in here, okay? When multiplying like bases, all right, so the base has to be the same. A times A, 5 times 5, 17 times 17, whatever it is, the base has to be the same. When you're multiplying like bases, we add the exponent. See that? A to the third power times A to the second power. We keep the base. It just slides over. We have A. And we do the 3 plus 2 to get A to the fifth power. Same thing, if it's 5 to the fourth power times 5 to the third power, we get 5 for our base, and it's to the 7th power. I talked about this in Chapter 5, all right? I really want you to watch Chapter 5 in my Algebra I playlist. When dividing like bases, we subtract the exponents. So remember, fractions are like little division problems. If we have x to the 5th power divided by x to the 2nd power, we have x to the 5 minus 2. See that? We're subtracting, so we get x to the 3rd power. X can't be 0, all right? If we have 3 to the 7th power divided by 3 to the 5th power, we subtract the exponents. 3 to the 7 minus 5, we get 3 to the 2nd power. Now, I really, really want you to watch all the Chapter 5 videos for Algebra I. You don't have to watch 5.12, but if you can watch all the other ones, it's going to help you pass the GED test. I know that's sidetracking you, but it's really important. If you want to pass this test, you need to understand these, okay? Now, it's also going to talk about, in the Chapter 5, how we can raise a power to a power. If we have x to the 3rd power in parentheses, and then it's squared outside the parentheses, we're going to multiply these two. When you raise a power to a power, we multiply them. When we're multiplying like bases, we add them. See that? But when we've got an exponent on the outside of parentheses and an exponent on the inside, we can just multiply those. 3 times 2 would be x to the 6th. See that? If it was 2 to the 3rd, and that was squared, it was raised to a higher power, then we would do the 3 times 2, and we would get 2 to the 6th. So basically what we're doing is, this 2 to the 3rd is 2 times 2 times 2, isn't it? Which 2 times 2 is 4, 4 times 2 is 8, so really we're saying 8 squared, which is 64. And if we do 2 to the 6th power, which we said it equals, 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. Look, see? So either way, It worked. So that's why when we're raising a power to a power, we can just multiply those exponents together. See? We talked about that in the Algebra I video 5.2. So if that confuses you, you need to watch the Algebra I Chapter 5 videos, all right? If we have 2x squared, well, that means we have 2 times x, because the exponent is only affecting the x as the base. See? We can raise a product to a power. So if we have 2x squared on the outside of the parentheses like this, it's affecting everything that's on the inside of the parentheses. That means we have 2x times 2x. Now, instead of x being the base, 2x is the base. See? Everything inside the parentheses is affected by that exponent. It's all the same thing as 2 times x times x. We also talked about that in video 5.2, all right? We can also raise a quotient to a power. So here we've got this rational number, this fraction inside of parentheses. This little 2 exponent affects everything inside the parentheses, the x and the y. It means we have x over y times x over y. See? If you saw x squared over y, well, that just means x times x over y. See the difference the parentheses made? This affected everything inside the parentheses. Now this just affects the x. See? And raising a quotient to a power, we have x to the third over y squared, and the whole thing is raised to the second power. We multiply the 3 times 2 and get an x to the 6. We multiply this 2 for the y times that 2 outside. See? And we get y to the 4th. And we can't subtract them because we don't have like bases. All right? And when we add terms with exponents, so when we're adding polynomials, we stack them so like variable terms are in columns. So if we have 5x squared, that's got the highest exponent, so that's going to go first. We've got plus 6x plus 1. So we put them in exponential order, and we can put them with the greatest exponent and then going down, or with the least going up. But you're usually going to see it with the largest exponent first in a polynomial. We put them into columns that match the terms. See? There's no x squared term, so this goes by itself right here, and it's just going to drop down. This 6x gets in the same column with this negative 7x. And this 1 gets put into the same column as the 2 because they're whole numbers, aren't they? When we add them, we just add them going straight down the column. This 5x squared is getting added to nothing, so it's just going to drop down. This positive 6x has a negative 7 being added to it, so it's going to be a negative 1, but we don't write the 1, do we? And 1 plus 2 is 3, see? Now, there's a lot more information about this, and that's in video 5.7a and 5.7b. Again, chapter 5. When we subtract terms with exponents, we can stack them so like variable terms are in columns, just like we did with the addition. We change subtraction to addition of the inverse. We use the distributive property when needed. So here's our problem. We've got the like terms stacked, okay? This one doesn't have an x squared, so we left a blank space here. This one doesn't have a whole number added to it, so we left that blank there. See that? We're going to do addition of the inverse. So instead of subtracting a positive x3 and a positive x squared, we're going to add addition of the inverse. We're going to add a negative x to the third minus x squared. See how we switched all the signs? Now we've got an x to the third power minus x to the third power. That makes a 0 pair, so we have nothing here. And we've got nothing here, so this negative x squared is just going to drop down, and there's nothing here, so this 1 is just going to drop down. We have negative x squared plus 1 as the answer. Now, there's a lot more to this also, but I'm trying to show you just this little touch of it. The GED book didn't even talk about this, all right? So that's Algebra I, video 5.8, and you'll learn about adding, subtracting, multiplying, and dividing polynomials that have exponents, okay? So you should now be ready to do that skill focus on page 235. and do your best. I think you're going to be okay. And watch as many videos as you can in my Algebra word problem playlist, because so many of the questions on this test are word problems. And you need to be able to put them into an equation and look at the clue words and then solve them, okay? So right now we're at the beginning of lesson 20. If you look at our chart here, lesson 27 is the last lesson. Lesson 23 starts geometry. So we've only got a couple lessons here to learn all of high school algebra. That's kind of a silly thought, isn't it? Just a few lessons to learn all of high school algebra? So, go to these videos. You can pause this video right here and write these down. What's going to really help you is watching this Algebra I, all of the Chapter 5 videos. You can watch these Algebra II ones too if you want. Okay? And if you're really confused, you can go back to the grade 5, grade 6, and grade 8 videos to get a running start before watching the Chapter 5 video. But you could try taking the test and fail it and say, I needed to go deeper because this book just glosses over everything, all right? So all these links are going to be in the description to help you. Our next video is going to be about square roots and the roots and that radical sign when you see that. It looks like a funny long division sign. That's a radical, okay? It's a radical sign. We're going to talk about that in square roots, okay? That's lesson 20B. I'm wishing you luck. You really don't need luck if you work hard, right? Just don't quit on me because I'm counting on you to make it through this, okay? Just, if you're having trouble, you retreat, regroup, and attack again, right? Don't give up. It's like beating the boss monster at the end of a video game, you know? You just keep trying, all right? If it gets too much, take a break, and then go back at it again. I'll see you next video. Bye.